So moving on to homework assignment 3F, so number 3. So we're talking about a stone being thrown up. So if it's being thrown up with an initial velocity, you make the initial velocity 30. And it's being thrown up from a cliff of 200 meters. So there's the S sub naught is 200. And because both of these are in metric system, I know that the acceleration of gravity is negative 9.8. So I'm going to go find my equation. So I have negative 9.8 t plus my initial velocity. And then my position function will be negative 4.9 t squared plus 30t plus 200. So those are my equations. So I'm asked to find the maximum height. So it's being thrown off of a cliff, going up and coming down. So I want to find out what this height is. So where it reaches, the time it reaches the maximum height will be when the velocity is equal to 0. So I'm going to set my negative 9.8 t plus 30 equals 0. So I'll get 30 over 9.8, and that gave me 3.06. Okay, so that's the time. So how do you find the height if you've got the time? Well, that's where you use this equation. So I'll let you go do the work, but if you put in time of 3.06, looks like you get 245 meters. All right, number 7 is next. So a rectangle is inscribed under this parabola, and this is y equal 4 minus x squared. Okay, so the rectangle sits on the x-axis and is inside, so that means the edges here touch the parabola. So find the side length of the rectangle that gives the largest area. All right, so I can see this distance will be an x and this distance will be an x. So the area of my rectangle will be 2 x's. And then this distance here for the height will be the y value of the function. So width times height is the area of a rectangle, right? So the width is all the way across. So the width is 2x. And then I just want to make sure everyone sees this. The height is the y. Okay, so now I'm going to use the equation that I know for the y. So that's 4 minus x squared. And because this is nice and easy to multiply out, I'm going to do it because it'll make my derivative easier. So if I take the derivative, I set it equal to 0. So I get x squared is equal to 4/3. So x is equal to plus or minus 2 over root 3. Okay, so to get the dimensions of the rectangle that's underneath, the width will be 2 of those 2 over root 3's. And the height of my rectangle will be the y value, so that's going to be 4 minus, and then put this in and square it, so 4 minus 4/3, right? So yeah, so there's the height and there's the width. All right, that was 7. So I had a request for number 8 as well. So number 8, find the antiderivative. So here's my function. The cube root of x, x minus 4. Okay, so I cannot do an antiderivative around multiplication, so I need to rewrite this. So I'm going to go slow, x to the 1/3. And so I multiply, I add exponents, right? So this gives me x to the 4/3 minus 4x to the 1/3. Okay, so that's my function. So the antiderivative is add 1 to the exponent, right? So I'd get 7/3 over 7/3, or times 3/7. Carry along the negative 4, add 1 to the exponent, so I'd get plus 3 over 3, so 4/3. Let me just go slow here. Divided by 4/3 plus a c. And I don't think they gave me information to solve for c in this one, correct. So 3/7 x to the 7/3, so minus 4, and then multiply by the reciprocal, right? So 3/7 minus 3, whoops, lost the x. 3/7 x to the 7/3 minus 3 x to the 4/3 plus c. All right, so number 9. So find L sub 4. So that means 4 rectangles, left-hand endpoints, and the function is x squared minus 3x, and it's on the interval between 1 and 5. On 1, 5. Okay, so the delta x is the first good thing to find. So that's 5 minus 1 divided by number of rectangles, and that's where you get that from here. So 4 rectangles. So that gives me a width of 1. So L sub 4, so the width of each rectangle is 1, and I'm using left-hand endpoints, so that means f of 1, plus width of the rectangle is 1, using the left-hand endpoint, that's going to be 2, plus width of the rectangle is 1, left-hand endpoint will be 3, plus, and then width of the rectangle is 1, left-hand endpoint is 4. So I should have 4 things because I'm adding up 4 rectangles using left-hand endpoints. So then what I'm going to do is I'm just going to use 1 into this function. So I get 1 minus 3. So here I get 9 minus 6, and then 9, oops, what happened there? No, that's 2 I'm plugging in, right? All right, plugging in 2, so I get 4 minus 6 plus, now I'm plugging in 3, 9 minus 9, oh my goodness, it must be 0 there, right? Plus, and then I'm plugging in 4, so I get 16 minus 12. And so remember, this is, just to get a picture of this, this is a parabola that crosses at 0 and 3, so it looks something like this, right? So we've got some rectangles below the x-axis and some above. So here I get -2 and a 0, and then a 4. Oh my goodness, it all adds up to 0. So the positive areaed rectangles above the x-axis and the rectangles below the x-axis cancel each other out, right? So there's these rectangles down here, and then this 0, 1, and these rectangles up here, and so they all cancel each other out. All right, one last one, number 10 from this homework 3F. So the position, find the position, whoops. Find S of t, and here I'm given A of t is equal to sine of t plus 3 cosine of t. And they give me some initial conditions. V of 0 is 2. Okay, so you know one antiderivative gets me to velocity. So I just think in terms of derivatives because I know my derivatives. What can I take the derivative of to get positive sine? So that's got to be negative cosine. What can I take the derivative of to get 3 cosine? So that's got to be 3 sine plus c. So then I'm going to use this right away. So put t equals 0 in. And I know cosine of 0 is 1, sine of 0 is 0. So then this gives me c equal 3. So let's fix up my velocity. Now I want to do another antiderivative. So what can I take the derivative of to get negative cosine? That's negative sine. What can I take the derivative of to get positive 3 sine? So that's going to be negative 3 cosine. What can I take the derivative of to get 3? That's going to be 3t. Be careful you don't put an x there. Plus c. All right, now I'm going to use this. So be careful with trig functions. Putting in 0 doesn't mean it's always 0, right? So I set it equal to 0, and I'm plugging in 0. So sine of 0 is 0. Cosine of 0 is 1, so I get a negative 3. That gives me a 0, so there's my c is equal to 3. So my final answer is S of t is negative sine of t minus 3 cosine of t plus 3t plus 3.